In example 2, we want to analyze this function f of x, and we have an e in there, so that'll be nice and fun. And we're going to start off with any asymptotes for this guy. This is an exponential function, so for our asymptotes, we know that there's only going to be one, and it's going to be a horizontal asymptote. If there is no vertical shift, if the graph is not shifted up or down any, then the horizontal asymptote is at y is equal to 0. If the graph has any vertical shift, in this case it does, then that horizontal asymptote will also shift. So if we look at this plus 2, it's not up here by the x, it's far away from the x, it's down in the regular script position, so this is going to be a shift up by 2. So we can say that our asymptote here is y is equal to 2, and if you want to put HA, that's fine, just to remind yourself that it's a horizontal asymptote. If we graph that here, we've got y is equal to 2 there. As far as points of discontinuity go, there's none for these. Remember that an exponential graph will be continuous. If we look at the domain then, we could do that one now or later, and the range now or later. The domain though for these are pretty easy. You can put just about anything you want up there. As a matter of fact, any real number will work for the x position. So we could write down negative infinity to infinity. The range then, this graph is not reflected, so the graph is going to be somewhere up here. The range would be not including 2. This graph cannot be exactly 2 up to infinity. Looking at our x-intercepts, the x-intercepts will occur when y is equal to 0. To solve this one, we need to use some knowledge of logarithms. And if we do that, I'm going to do that off here on the side actually, because this might be a little bit of work. So we'll do that over here on the right hand side. We've got this f of x here, which is, we're saying that's now 0, is equal to e to the x minus 1 plus 2. Subtracting 2 from each side, and again, what we're doing here is we're finding the x-intercept. Put a label up there for you. The x-intercept just occurs when y is equal to 0. So we've got, we'll do e to the x minus 1 is equal to negative 2. I find this the simplest thing to do here would be to take the natural log of each side. And then we've got the natural log of negative 2, so we can pull the x minus 1 out, and the natural log of e is just 1. So we've got x minus 1 is equal to the natural log of negative 2. Adding 1, we're going to try to evaluate this. Now there's a problem here. The problem is this position, the argument position. It is negative. That is definitely not allowed. I mean, even if you type this in your calculator, and I'll show you what will happen if you do that. You can type in natural log here of negative 2, and says non-real answer. There's nothing you can raise e to. Any power of e cannot be negative. So in this case, it doesn't work. This means to you that there is no x-intercept. And if we look at the way that the graph is going to be here, this graph is going to exist somewhere here, and it will never get down to this position because it's not going to go below the horizontal asymptote. So we could write maybe none. That would work. There's no points of discontinuity. There's no x-intercepts. Y-intercepts, there's totally going to be a y-intercept. To figure this one out, all we need to do is just plug in 0 for x. So you can see to find the x-intercept, you plug in 0 for a y. For the y-intercept, you plug in 0 for x. And we'll see what happens here. So we've got y is equal to e to the first, which is just e, plus 2. This would be the exact answer. If you want to write an approximation, that's fine too. It's of course super helpful for graphing. So we could go to our calculator, type in e plus 2. I'd highly recommend just using the value that's stored in your calculator, just like you do with pi. They're not the same number, of course, but they're similar. Pi stands for a value, and so does e. And if you type that in, you've got 4.7, and it keeps on going. This one, I think, for us to be useful in graphing, let's round to the nearest tenth. So we'll go about 4.7. At this stage of the game, we can now graph. And if we graph this, we can go up 4.7, and we know that the graph is going to continue up in this direction, continue down, and get very, very close to this horizontal asymptote. If you were asked to make a chart or plot at least 3 points, then all you would need to do is just substitute in other values of x and find the corresponding values of y. For our purposes here, for analyzing this function, we've got a pretty good graph, and I'll show you what the graph looks like in the graphing calculator. So ours isn't perfect, but it does look pretty good. The end behavior then will be what the ends of the graph are doing in terms of their values, or their y values. So we can go x approaches infinity here. What does y do? As we go to the right, and you can pick any number to the right, any number will work. This graph is going, the y value, the up and the down value, is going to infinity. As x approaches negative infinity though, this graph is leveling out and approaching or getting close to the horizontal asymptote of 2.